In 2022, the James Webb Space Telescope focused on a section of sky tinier than a single grain of sand balanced at arm's reach. What it revealed inside was staggering over 25,000 galaxies, every one of them home to hundreds of billions of stars. We believe we understand the true enormity of the universe, but the numbers tell a different story. Today, you and I journey from our galaxy all the way to the farthest boundary of the observable cosmos. We discover galaxies that formed before they were supposed to. We chart a supercluster stretching 500 million light-years across. We arrive at the edges of voids that physics still cannot fully account for. If this resonates with you, like and subscribe. It truly matters. Now, take a breath. Let us begin. In July of 2022, NASA unveiled an image that left scientists speechless. It had been recorded by the James Webb Space Telescope, the most advanced observatory humanity has ever constructed. The image spanned a section of sky tinier than a single grain of sand balanced at arm's reach. That minuscule, almost absurdly small strip of darkness held over 25,000 galaxies. 25,000. Every single one a gathering of hundreds of billions of stars. Some rotating, some crashing together. Some so incredibly old that the light reaching us had been on its way since before our world came into being. Here is what made it even more remarkable. The telescope gathered all of that in merely 12.5 hours. The Hubble Space Telescope, which had revolutionized astronomy for generations, required 11 complete days to achieve a similar depth. Webb accomplished it in half a day. And what it uncovered in that minuscule strip of sky compelled astronomers to rethink everything. Now, keep this in mind. The visible sky can be split into approximately 540 million such grain of sand sections. If every single one conceals galaxies at the same concentration, the figures cease making sense to the human mind almost instantly. But they are accurate. This is verified. That image formed part of a program called Cosmos Webb. When that initial capture was produced, it accounted for only 4% of the planned whole. 4%. Astronomers had only just begun scratching the surface, and the outcome was already transforming expectations. Caitlin Casey, an astronomer at the University of Texas at Austin, expressed it directly. When it is completed, she said, "This deep field will be astoundingly large and overwhelmingly beautiful. Reflect on what that signifies personally. Every one of those 25,000 galaxies has been resting in that section of sky for your entire existence. Every evening you walked outside and gazed upward. They were present, unseen, waiting. Your unaided eye can only span a fraction of a percent of the distance to the closest of those galaxies. The James Webb Space Telescope pushed our vision into realms we had never accessed. The telescope was directed at a cluster of galaxies approximately 4.6 billion light-years distant. That cluster functions as a natural gravitational lens, warping and amplifying the light of even more ancient galaxies positioned far beyond it. Some of those amplified galaxies came into existence when the universe was so juvenile that stars were still scarce, delicate, freshly ignited. What a single photograph accomplished was remarkable. In 12.5 hours, Webb revealed more of the universe's stacked history than decades of earlier observation had achieved. Stars igniting, galaxies merging, light stretched so extensively across space that it arrived as infrared, entirely invisible to human eyes, registerable only through instruments. We had long suspected the universe contained more than we could perceive. But suspecting and verifying are two completely separate matters. What Webb verified was staggering. That grain of sand section holds more stellar islands than there are grains of sand on a sprawling beach. If the universe appears like this in every direction, and all data supports that it does, then the total count of galaxies around us is well past any earlier prediction. The question was, how numerous? That answer had actually come years before Webb was deployed. And when it arrived, it increased the former total by 10. For much of the 20th century, the accepted figure for the number of galaxies in the observable universe rested between 100 billion and 200 billion, breathtaking by itself. But researchers thought they had a reasonable grasp on the sum. Then, in October of 2016, a group led by Professor Christopher Consolis at the University of Nottingham released a study that quietly shattered that assumption. They devoted years to transforming Hubble deep space imagery into three-dimensional charts. They gauged galaxy density at varying distances throughout cosmic time, determined how many galaxies were too dim or too tiny for even Hubble to register, and projected the complete total. The conclusion was definitive. The observable universe holds at least 2 trillion galaxies, 10 times greater than formerly calculated. 2 trillion. Consolis characterized the response plainly. It boggles the mind. He stated that over 90% of the galaxies in the universe have yet to be examined. Who knows what fascinating qualities we will uncover when we locate them? That final sentence holds a distinct significance. Of those 2 trillion, our finest telescopes can presently detect around 200 billion, approximately 10%. The remaining 1.8 trillion are out there right now, established by the mathematics of cosmic density, hidden from us only because they are too dim, too remote, or too compact for existing instruments to pick up. They are present. They harbor stars. They very likely harbor planets. We just cannot access them with what we have constructed thus far. Here is why this is important beyond the raw magnitude of the figure. Every cosmological calculation you have ever encountered was founded on a baseline that was wrong by a factor of 10. The universe was always this packed. We simply were not probing deeply enough to notice it. Now contemplate the arithmetic at the revised scale. If each of those 2 trillion galaxies holds an average of 200 billion stars, the total count of stars in the observable universe arrives at something near 400 sextillion. That is a 4 trailed by 23 zeros. No human faculty of imagination can contain that number. It surpasses the upper limit of comprehension. And here is something worth considering beside that figure. These 2 trillion galaxies are not uniformly spread through time. In the early universe, there were actually 10 times as many galaxies per unit of volume as there are now. Early galaxies were more compact, more turbulent, more plentiful. Across billions of years, they crashed, combined, and consumed each other into bigger, steadier formations. What we witness today is the product of 13.8 billion years of merging. The original total was even greater. Consider what it implies that 90% of the universe's galaxies stay entirely unexplored. Astronomers calculate that each of those concealed galaxies possesses its own stars, its own possibility for planets, its own chronicle. We have records of everything humanity has ever investigated in space. Every mission, every telescope capture, every verified finding, and all of that together amounts to 1/10 of what actually populates the observable universe. The remainder is out there waiting. Every one of those galaxies, ancient or modern, close by or unimaginably distant, is composed of light that has been crossing a stretching, expanding universe for an extremely long duration. And the following part of this narrative drives that light back to its furthest extreme to merely 290 million years after the start of everything. Because what the James Webb Space Telescope detected there should not have been possible. In May of 2024, a group of astronomers revealed that Webb had verified the most remote galaxy ever detected. The LACY catalog designation is not the point. What counts is what it discloses about the infant universe. This galaxy was present just 290 million years following the Big Bang. To comprehend why that is astonishing, consider what the universe resembled at that instant. It was predominantly hydrogen and helium, still scorching and compressed and disordered. Stars had only just started forming for the initial time. Galaxies, the vast coordinated structures we identify today, had no reason to exist yet. Building structure demands time. Gravity requires multiple cycles of stellar development to construct something that elaborate. And yet there it stood, validated by spectroscopy. A galaxy already tens of thousands of light-years wide, radiating in a universe scarcely mature enough to possess stars. The light from that galaxy departed its origin 13.5 billion years ago. At that juncture, Earth was non-existent. Our solar system had not coalesced. The gas that would someday compress into our star was still wandering freely through space. That light traversed the full breadth of cosmic history and landed on Webb's mirror just a handful of years ago. Kevin Hainline from the University of Arizona characterized the discovery this way. "We genuinely should not have located a galaxy like this," he said, "based on our grasp of the manner in which the universe has developed." That statement carries significance. This is a validated spectroscopic reading from one of the most accurate instruments ever engineered. And it is informing us that our frameworks for early galaxy assembly are lacking something crucial. In early 2025, a second primordial galaxy grabbed attention. Published in the journal Nature, it took shape just 330 million years following the Big Bang. This one radiated with a variety of light known as Lyman alpha emission, which should have been entirely obstructed at that period. The infant universe was saturated with a dense haze of neutral hydrogen that captures this particular light. For it to break free meant the haze surrounding that galaxy had already dissipated. But dissipating that haze should have required hundreds of millions of additional years. Roberto Maiolino from the University of Cambridge described the response simply. This outcome, he said, was completely unanticipated by theories of early galaxy assembly and has taken astronomers off guard. The pattern taking shape here is obvious. The infant universe was more dynamic, more organized, and more forceful in galaxy creation than our strongest models forecasted. Galaxies materialized sooner. They expanded quicker. Something within those opening few hundred million years remains unexplained, and this extends beyond scholarly interest. Our frameworks of the universe, the ones that forecast its destiny and characterize its architecture, are constructed on assumptions regarding how rapidly galaxies assembled and expanded. If those assumptions are incorrect, the entire structure demands revision. Astronomers are actively reworking it at this moment, utilizing every image Webb transmits back. Each fresh validation of an early galaxy alters the chronology we believed we had mastered, which introduces a difficulty with distance itself that the majority of people never learn about. Because if you attempted to research how far away these primordial galaxies truly are, the figures would not reconcile. They cannot unless you appreciate something profoundly unusual about how space and time connect to each other. Here is the riddle. The universe is 13.8 billion years old. Light moves at just below 186,000 meters per second, the fastest anything can travel. In principle, the greatest distance any light could have covered is 13.8 billion light years. So that ought to be the boundary of the observable universe. It is not. The boundary of the observable universe rests 46.5 billion light years distant. In every direction that creates a sphere 93 billion light years in diameter. And this does not violate physics. It exposes something about the character of space that is even more peculiar than the dimensions themselves. The Big Bang was not a detonation of matter through already existing space. Space itself stretched outward. The universe did not expand into something beyond itself. The gaps between everything grew wider as the fabric of space elongated, and that elongation has never ceased. When the most ancient light in the observable universe was initially emitted about 380,000 years following the Big Bang, the zone that produced it was much nearer to us than it is at present. While that light spent billions of years journeying toward us, the universe continued stretching behind it. The origin kept being transported further away. By the moment the light reached us, the zone it departed from had been displaced to a present distance of 46.5 billion light years. This is established by multiple independent measurement techniques. The figures align. Picture it like hurling a ball across a river while the river is broadening. The ball moves at a constant speed, but the opposite bank keeps shifting away as the ball is airborne. The ball still arrives, but the location it originated from is now considerably farther than when it was launched. That is what light does traversing an expanding universe. The proportion is worth absorbing. The boundary of the observable universe is presently 3.4 times more distant than the age of the universe by itself would imply. Every moment you remain here, the most faraway things we can detect are being driven further away by continuing expansion. There is a figure linked to this expansion. For every 3.2 million light-years of separation, galaxies are withdrawing from us at roughly 43 meters per second faster. A galaxy 1 billion light-years distant is retreating at approximately 13,000 meters per second. A galaxy 10 billion light-years distant is withdrawing at a considerable portion of the speed of light. And, past roughly 18 billion light-years, the withdrawal speed surpasses light speed altogether. Not because those galaxies are traveling through space faster than light, but because the space separating us from them is stretching faster than light can traverse it. Those galaxies are lost. Their light will never arrive here. Already the overwhelming majority of the universe. Verified calculations suggest approximately 94% of it lies past any feasible contact. And that threshold is contracting very gradually each year. The force propelling that expansion is termed dark energy. It will resurface later in this account in a far more disturbing context. For the moment, the crucial point to retain is this. The observable universe is a sphere 93 billion light-years in diameter. That is the arena we are operating within. And before we venture further out, we need to grasp where we are positioned inside it. Because there is one analogy, a straightforward one that renders the complete scale apparent at once. Visualize a matchstick about an inch and a half long, slender, and ordinary. Now envision that matchstick is the Milky Way galaxy. The whole thing, every star within it, every cloud of gas, every nebula, every black hole, every planet, all of it from one side to the other compressed into 1.5 inches. At that identical scale, the observable universe would be a sphere with a radius of roughly 1.3 miles. One matchstick, 1.3 miles. That is the proportion between our home galaxy and everything we can detect. The scale factor is approximately 1 to 450 billion. 180,000 light-years compressed by 450 billion yields roughly 1.5 inches. This is established by direct computation. Now reflect on what that implies in reality. Those 2 trillion galaxies we examined at this scale would each be approximately the dimension of a matchstick. All 2 trillion of them dispersed through a sphere you could jog across in roughly half an hour. Each matchstick would be divided from the next by approximately 5 to 10 feet of vacant air, predominantly empty intervals of darkness between each island. The universe is thinly spread even at the scale of galaxies. If you wished to journey from our matchstick to the closest other major galaxy, Andromeda, at this scale, that voyage would be roughly 6.5 feet. But in actual terms, it is 2.5 million light-years, approximately 15 million trillion miles. And this whole matchstick universe, every galaxy, every cluster, all of it inside the 1.3-mile sphere, represents solely the portion of space we can actually observe. The total universe almost certainly reaches far beyond that sphere. How far beyond is a matter for later. There is something else to recognize at this scale. If you arranged those 2 trillion matchstick galaxies and distributed them uniformly across that 1.3-mile sphere, the typical gap between adjacent matchsticks would be approximately 5 to 10 feet of vacant air. The universe is predominantly emptiness. Even at the scale of galaxies, the prevailing characteristic of the cosmos is vacancy. Galaxy clusters are compact knots. Between them, immense dark expanses hold virtually nothing for hundreds of millions of light-years. You are situated inside one of those matchsticks. At this very instant, every ocean, every mountain chain, every city, every individual who has ever existed lies within the confines of 1.5 inches of that scale. Everything else is separation, distance, silence. But before we investigate what occupies those intervals, we need to examine our matchstick closely. Because even at this diminished, nearly invisible scale, what it holds is already past the mind's capacity to fully envision. There is one additional detail worth drawing from this analogy before we proceed. At this scale, the closest individual star to our solar system, Proxima Centauri, which rests approximately 4 light-years away in actual terms, would be roughly 1/5 of a millimeter from us, practically touching. And yet, even at that impossibly short distance on this scale, no human vessel has ever approached reaching it. The swiftest probes we have sent would require tens of thousands of years to cover that 1/5 of a millimeter. The Milky Way, which resembles a small, uncomplicated thing at this scale, holds over 200 billion stars. And what that quantity truly signifies when you attempt to internalize it, rather than simply recite it, is already sufficient to fracture something in how you comprehend magnitude. 200 billion stars in the Milky Way at the lower calculation. Some estimates place the figure nearer to 400 billion, once you factor in the concentrated stellar population concealed in the galactic nucleus by dense clouds of gas and dust. Here is one method to render that number tangible. If you tallied one star per second without resting, without halting, you would complete the count between 6,000 and 12,000 years from today. Every civilization that presently exists on Earth would have emerged and crumbled numerous times over before you reached the final star. The complete duration of documented history would unfold repeatedly in the background while you counted. Our galaxy encompasses a variety of stellar classes. The majority are small, faint red dwarfs, stars that consume fuel gradually and reliably and can persist for tens of billions of years. Some are enormous, dazzling blue giants that deplete their reserves in merely a few million years and then detonate. Our own star is halfway through its life, dependable, and situated roughly 26,000 light-years from the galactic center. At that center, established by 3 decades of direct tracking, resides a supermassive black hole designated Sagittarius A star. Its mass is roughly 4 million times the mass of our star. Groups of astronomers monitored individual stars circling it at tremendous velocity for over 30 years, mapping precise trajectories around an unseen point and established its existence beyond any credible question. This is settled science. The light we collect from the galactic center tonight departed its source 26,000 years ago. When that light started its passage, humans on Earth were deep within the last ice age, decorating cave walls, traversing land corridors with no written language and no lasting communities. Our solar system is revolving around that center right now, together with everything else in the galaxy. One full revolution requires between 225 million and 250 million years. The previous time our solar system finished a complete circuit, dinosaurs were still in the early stages of their era on Earth. Across the entire existence of our galaxy, the solar system has finished approximately 60 of these revolutions. We have been circling this path since before the earliest fish grew lungs. The velocity we are maintaining is approximately 514,000 miles per hour. That is remarkable by any human measure. A spacecraft traveling at that rate could arrive at the Moon in roughly 28 minutes. And yet at that velocity, a single galactic revolution still consumes 250 million years. And every star you have ever spotted with your unaided eye, every constellation recognized since youth, is a component of this formation. The farthest star observable without a telescope rests a few thousand light-years distant, still firmly within the Milky Way, still contained in that 1.5-inch matchstick. Everything past that belongs to a different galaxy. And past our galaxy, just a modest distance away on cosmic measurements, the initial neighbors emerge, dozens of them, connected to us by gravity, comprising a small community traveling together through space. Every star you recognize, every one that carries a name, every one that features in the mythology of any culture that has ever existed on Earth is within our galaxy. All of human sky gazing, from the earliest observers to the original telescopes, was only ever directed at stars inside this lone structure. We had no awareness there were others until roughly 100 years ago. That is how recently our comprehension of our own location in the universe was fundamentally altered. But one of those neighboring galaxies is heading directly toward us, and the schedule is already determined. The Milky Way is part of a gathering of galaxies known as the Local Group. It includes over 50 members, although most are small dwarf galaxies revolving around the two biggest, our galaxy and the Andromeda Galaxy. The local group extends roughly 10 million light-years from one side to the other. That is 100 times the width of the Milky Way itself. Largely vacant space peppered with dozens of gravitationally linked islands. Andromeda rests 2.5 million light-years from this location. The light you observe from it tonight departed its origin 2.5 million years ago, when our predecessors were primitive hominids on the African grasslands. Before fire, before speech, before any implement more advanced than a rock, that primordial light is reaching your eyes at this very instant. Andromeda holds approximately 1 trillion stars, probably more than the Milky Way, and it is advancing toward us. This is established. Both galaxies are closing on each other at approximately 70 meters per second. In roughly 4.5 billion years, they will start to collide and combine. The combination will play out across hundreds of millions of years. Individual stars are so broadly separated that extremely few will physically strike each other. But the gravitational interactions will be tremendous. Both galaxies will be ripped apart and reformed into a new merged structure sometimes referred to as Milkomeda. Gas clouds will be squeezed, sparking powerful bursts of fresh star creation. Stars will be hurled to different orbits far from their initial locations. What results will bear no resemblance to how either galaxy looks at present. The research here is definitive. The closing speeds are quantified. The schedule is validated by orbital dynamics. It will occur. Our solar system will most probably endure the combination undamaged. The likelihood of a direct star-to-star impact is vanishingly small, given the vast empty space dividing individual stars. But our placement in the combined galaxy will shift considerably. Present simulations indicate our solar system might be flung outward to a far greater orbit, or even into the expanded outer envelope of the new formation. From that perspective, the night sky would appear entirely unfamiliar. The recognizable spiral arms would be absent, substituted by the scattered luminescence of an elliptical galaxy still adjusting from the impact. There is additionally the Triangulum galaxy, approximately 2.7 million light-years distant, more modest than either Andromeda or the Milky Way, but still housing tens of billions of stars. Past it, over 50 tinier dwarf galaxies round out the local group. Most of them satellites revolving around the bigger participants. Collectively, connected by gravity, these galaxies drift through space as one body, and as one body they are descending, drawn toward a concentrated assembly of galaxies 54 million light-years away. A metropolis of more than 1,000 galaxies where nearly a century ago, one researcher observed that something unseen and colossal was lurking in open view. The local group itself is traveling through space at roughly 1.4 million miles per hour relative to the cosmic microwave background. That is the radiation remaining from the Big Bang which permeates the whole universe, and serves as the nearest equivalent we possess to a stationary reference frame. Relative to it, our complete archipelago of galaxies, everything within it, every star, every planet, every atom of matter we have ever encountered, is rocketing through space at velocities that overwhelm anything ever manufactured by human civilization. What that researcher uncovered while examining a cluster, much like the one we are descending toward, would transform our entire comprehension of what the universe consists. Of 54 million light-years from this position, a concentrated metropolis of galaxies awaits. It is named the Virgo cluster. Over 1,300 galaxies occupy this territory. Most of them modest dwarf systems revolving around a condensed inner nucleus. At that nucleus sit several of the most massive galaxies we have ever recorded. Enormous elliptical formations swollen from billions of years of ingesting smaller galaxies individually. The Virgo cluster serves as the gravitational anchor of our regional universe. The Milky Way, the local group, and all adjacent galaxy clusters are gradually descending toward it. This is established by precise velocity observations conducted across decades. The attraction is genuine and continuous, and it has been influencing the trajectory of our galaxy for billions of years. But the Virgo cluster holds its greatest importance in this account for what it helped expose about something unseen. In 1933, a Swiss astronomer called Fritz Zwicky was examining a different, concentrated metropolis of galaxies known as the Coma Cluster, situated roughly 320 million light-years from Earth, harboring approximately 1,000 galaxies. Zwicky measured the speeds at which the galaxies within it were traveling relative to one another. He then computed how rapidly they ought to be traveling based solely on the observable mass available. The figures did not correspond in any way. The galaxies were traveling much too rapidly. The observable matter in the cluster, all those stars, all that gas supplied nowhere close to sufficient gravity to bind them together at those velocities. Something additional was present, something possessing tremendous mass and gravitational force. Something that produced no light and engaged with nothing except through gravitational attraction. Zwicky labeled it dark matter. He issued his conclusions, and the scientific establishment largely disregarded him for decades. The notion was too outlandish. Unseen matter constituting the bulk of the mass in a galaxy cluster appeared like an unjustified extrapolation. His techniques were challenged. The concept lingered at the margins of mainstream discourse for close to 40 years. When separate investigators finally re-examined the proof in the 1970s, employing entirely different approaches, including measuring how rapidly stars revolve around the outer margins of spiral galaxies, they encountered the identical anomaly everywhere they investigated. Something unseen and enormously heavy was present in every galaxy they analyzed. Zwicky had been correct, and the ramifications were greater than anyone had foreseen. Because if dark matter is genuine, then everything we have ever witnessed through a telescope constitutes only a portion of what truly exists. Subsequent studies reinforced Zwicky's initial assertion. In the 1970s, astronomer Vera Rubin and her collaborator Kent Ford gauged how rapidly stars revolve around the outer margins of spiral galaxies. Stars distant from the hub should be traveling more slowly, exactly as the outer planets of our solar system travel more slowly than the closer ones. They do not. Stars at the farthest reaches of galaxies revolve just as rapidly as stars nearer in, occasionally faster. The sole explanation that works is that a vast, unseen mass reaches far past the visible margins of every galaxy we can observe, supplying additional gravitational force throughout the entire formation. This unseen mass has never been directly registered by any apparatus. Not a single particle of dark matter has ever been isolated in a laboratory. Its nature remains as of 2026 entirely unresolved. The Virgo cluster, the Coma cluster, and every formation we have examined thus far are situated within a grand unseen framework we are only starting to chart. And in 2014, Astronomers followed that framework to outline the biggest confirmed formation our galaxy has ever been demonstrated to be part of. For much of the 20th century, the local supercluster, a dispersed collection of galaxy groups covering approximately 100 million light-years, was regarded as the biggest formation our galaxy belonged to. It appeared to be the upper limit of our cosmic address. In 2014, that upper limit was torn down. A group led by R. Brent Tully at the University of Hawaii constructed something novel, a chart founded entirely on movement. They monitored the peculiar velocities of roughly 8,000 galaxies, the minor deviations from the general expansion of the universe that betray the gravitational influence of neighboring mass. By following where those velocities were directed, they charted the margins of the gravitational depression that binds our sector of the universe together. They christened it Lania Kea. The term derives from Hawaiian and translates to immense heaven. Lania Kea stretches 520 million light-years in breadth. It encompasses at least 100,000 galaxies arranged across 300 to 500 clusters and groups. Its aggregate mass is roughly 100 quadrillion times the mass of our star. This is established, published in the journal Nature, and validated by numerous following studies employing independent data collections. The Milky Way rests near the outer margin of Lania Kea, nowhere close to its heart. Streaming toward the heart from our location, tracking the gravitational current, like water trailing a gradient, are hundreds of thousands of galaxies. That heart is a zone astronomers designate the Great Attractor. It sits roughly 220 million light-years away in the direction of the Norma galaxy cluster. For decades, it was obscured behind the thick gas and dust of our own galaxy's midplane, rendering it virtually impossible to study directly. When astronomers eventually charted around this blocking zone using alternative wavelengths, they discovered a massive accumulation of mass, pulling everything in its neighborhood toward it. Our galaxy is caught in that current. It has been for billions of years. Tully articulated the concept clearly. Just as streams flow within drainage basins, galaxies flow within cosmic basins of attraction. Lania Kea is the drainage basin our galaxy inhabits. But here is something worth highlighting about our location within it. We are near the outer perimeter. We are on the fringe of a supercluster so expansive that light requires over 1 billion years to traverse it. And we reside near the periphery, not at the core. In cosmic terminology, we are in the outskirts. The concentrated center of Lania Kea, where clusters press together and gravitational dynamics are vigorous, rests hundreds of millions of light-years from our solar system. This finding also transformed how astronomers delineate cosmic formations. Before Tully's research, supercluster edges were established based on where galaxies seem to gather visually. After it, edges were established by gravity, by where matter is being drawn together instead of where it happens to be seen. That is a more substantive boundary to trace, and when you trace it that way, the formation you identify is substantially bigger. Something in the measurements pointed even further. Even as the Lania Kea edges were being validated, peculiar velocity readings at grander scales were suggesting an attraction from something much more remote. Something 650 million light-years out, something 10 times bigger than Lania Kea itself. And in 2024, a fresh study made that suggestion considerably harder to dismiss. In October of 2024, the Cosmic Flows Research Group published new results in Nature Astronomy. They had compiled the most accurate and thorough chart of galaxy movements ever produced, documenting the trajectories of thousands of galaxies spanning hundreds of millions of light-years. And what they identified was a signal they had not anticipated. There is a 60% likelihood, their analysis determined, that the Milky Way is gravitationally linked to the Shapley concentration, an enormous formation positioned 650 million light-years away. Harlow Shapley originally identified this zone in the 1930s as a notable clustering of remote galaxies in the direction of the constellation Centaurus. It appeared denser than the adjacent universe, but without the instruments to gauge its complete size or mass, its actual character remained ambiguous for decades. When astronomers at last charted it thoroughly, what they discovered was immense. The Shapley concentration contains over 25 rich galaxy clusters. Its overall volume is approximately 10 times greater than the entirety of Laniakea. It constitutes the single densest mass concentration in our regional universe, a gravitational entity so immense that its pull reaches hundreds of millions of light-years in every direction. What the 2024 study revealed was that the velocity current of our galaxy and the neighboring territory seems to aim toward the Shapley concentration, implying a gravitational relationship functioning at a magnitude nobody had previously attributed to our cosmic address. This is still recent research. The 60% likelihood reflects authentic, honest uncertainty. Additional survey information, especially from continuing velocity charting initiatives, will be required to elevate that confidence or adjust it downward. The research is active and continuously being evaluated. Tully described the wider picture. The identification of these grander basins could fundamentally alter our comprehension of cosmic architecture. There is a recurring theme woven through everything we have explored so far. Every time astronomers widen their view one step, the formation above is grander than the models anticipated. The local group connects to the Virgo cluster. The Virgo cluster resides within Laniakea, and now Laniakea may be streaming into the Shapley concentration. Each tier exposes something greater. Each resolution introduces a question one dimension bigger. What makes this recurring theme troubling is what it suggests about our understanding of where we reside. Humans have been mapping the cosmos for centuries. We cataloged planets, charted stars, identified galaxies, and assembled increasingly refined portraits of the universe's large-scale architecture. And at every phase, the actual magnitude proved greater than we imagined. Not by minor increments, by multiples of 10, by multiples of 10 times 10. The cosmic address we assumed was finished keeps receiving another level stacked above it. And yet all of it, from the Milky Way to the prospective Shapley Basin, occupies the observable universe the way a solitary raindrop occupies an ocean. Because the subsequent tier of structure in the universe is not gauged in millions or even hundreds of millions of light-years. It is gauged in billions, and it links every cluster and supercluster into a single enormous framework, spanning the complete observable sky. That framework has a designation, and between its strands lie territories of emptiness. So severe they provoke questions that physics has not entirely resolved yet. The framework linking every cluster, every supercluster, every formation we have explored has a designation. Scientists term it the cosmic web, and when astronomers eventually charted it, what they observed did not resemble a haphazard scattering of galaxies through empty space. It resembled something organic. The cosmic web is a three-dimensional lattice of filaments, sheets, junctions, and voids extending across the complete observable universe in every direction. It is genuine, established by 4 decades of independent survey information, and it is the most extensive coherent formation in existence. The first detailed chart of it materialized in 1985 when astronomers Margaret Geller and John Huchra at the Harvard-Smithsonian Center for Astrophysics finished a survey of thousands of galaxies and mapped their locations in 3 dimensions. What materialized on the display stunned observers. Galaxies were organized along sheets and strands between them vast empty territories. The universe possessed texture. It possessed scaffolding. The cosmic web had been concealed in plain view, awaiting a survey comprehensive enough to expose it. Those filaments are colossal. Individual threads extend hundreds of millions of light years. They are constructed primarily of dark matter, unseen by every telescope, with luminous galaxies adhering to their outer surfaces the way frost accumulates along a wire. The matter you can observe is merely the bright fringe of something considerably more massive beneath. Here is where something unanticipated enters the narrative. In 2020, a group of scientists discovered that these filaments rotate. The most extensive filaments in the cosmic web turn around their own extended axis like gradual cylinders of matter revolving in the darkness. They are now categorized as the most extensive rotating objects ever cataloged in the observable universe. The process generating this rotation is still under investigation, but the detection itself is established. In 2021, astronomers pinpointed an ancient filament that assembled just 830 million years following the Big Bang. It already housed 10 galaxies stretched over 3 million light years. The web was organizing itself well before the majority of models forecasted. That revises what we believed we understood about how early the universe assembled into formations where the filaments intersect each other. Gravity accumulates matter into the most concentrated junctions in the observable universe. Every enormous formation examined thus far, the Virgo cluster, the Great Attractor, the Shapley concentration occupies one of these crossings. They are not standalone entities. They are knots in a web joined to each other by unseen threads covering billions of light years. And then there is the other characteristic of the web, the one that prevails by volume. Between the filaments, enormous territories hold, virtually nothing. No galaxies, no gas formations, no stars, merely space. Cold, dark, nearly barren space. These voids constitute approximately 95% of the entire volume of the observable universe. The universe is not predominantly galaxies. The universe is predominantly nothing. The galaxies and filaments are the minority compressed into a small fraction of the total volume, like froth on the surface of an ocean. Computer renderings of the cosmic web at grand scales generate images that consistently astonish observers. The formation looks precisely like a human brain. A neural network, elaborate branching, concentrating at junctions, extended threads linking remote concentrations. Scientists have remarked on this similarity in peer-reviewed publications. It is a structural comparison, not a metaphor. Networks molded by analogous constraints, whether gravity or electrochemical transmission, arrive at comparable configurations. But the most extreme manifestation of what the web generates is located in its vacant territories, and one of those territories found over 40 years ago is expansive enough that traveling through it at the speed of light would consume more time than complex animal life has occupied Earth. In 1981, a group of astronomers directed by Robert Kirshner was performing a methodical survey of galaxies in the constellation Bootes when they detected something amiss. An extensive stretch of sky that should have held approximately 2,000 galaxies held practically none. 60. Out of 2,000 anticipated, 60 were located in a territory of space approximately 250 to 330 million light-years in extent. The concentration of matter within was roughly 10% of the cosmic norm, established by subsequent surveys across the decades since. This is not a statistical anomaly or product of partial data. The Bootes void, as it came to be designated, is genuine. It is enormous and it is peculiar. Here is the comparison that makes the dimensions tangible. The Milky Way is approximately 100,000 light-years in extent. The Bootes void could accommodate 3,000 Milky Way galaxies, arranged end to end through its breadth with space remaining. Positioned roughly 700 million light-years from here, it constitutes one of the most striking underdensities anywhere in the observable universe. If you could traverse it at the speed of light, the voyage would require over 250 million years. That figure warrants a pause for reflection. 250 million years of traveling at the absolute maximum velocity permitted by physics through a territory virtually stripped of any stars, any planets, any formation at all. For nearly the complete journey you would observe nothing. No luminous galactic arms, no brilliant clusters, merely the subtle glow of the cosmic microwave background and blackness ahead. 250 million years is approximately how long complex animal life has existed on our planet. The complete span from the earliest fish with limbs to every civilization that has ever emerged and vanished. All of that duration compressed into a single traversal of one void. The 60 or so galaxies that do persist inside the Bootes void are atypical. Many display irregular configurations, elevated gas volumes, and sustained star production powered by internal dynamics rather than the external conditions galaxies in more populated territories encounter. Some seem organized in a subtle filamentary arrangement, a miniature reflection of the broader cosmic web assembling within the emptiness itself, a web inside a void. Gravity cannot resist itself. Even in the most barren territories of the observable universe, matter discovers a way to reach toward other matter. Now, here is the aspect that should provoke a particular variety of disquiet. The Bootes void is peculiar and enormous, but it is also comprehensible within standard cosmology. Gravity can evacuate a territory that size across the age of the universe. The models permit it, even if grudgingly. What cannot be so readily absorbed is the question of whether the Bootes void is an extreme anomaly, or whether it is simply the most conspicuous instance of something considerably more widespread. The cosmic web populates the observable universe with voids of every dimension. Most are more modest, some are grander, and the grandest confirmed instance of all does not rest somewhere remote in the sky. It envelops us entirely. Standard cosmological frameworks can account for the Bootes void. At 330 million light-years, it falls within the span of formations that gravity could have emptied across the universe's lifespan. The theory anticipates voids of this magnitude can develop, although they persist as extreme anomalies. So, the Bootes void is established, thoroughly investigated, and scientifically explicable, if profoundly unsettling. What follows is more difficult to account for because there is a void vastly grander than the Bootes void, and we are situated within it at this very moment. Everything, we have charted thus far rests within an underdense territory of space approximately 2 billion light-years in extent. The Milky Way, the local group, Laniakea, the Shapley concentration, all of them reside inside a cosmic wasteland where the typical concentration of matter is roughly 30% beneath the remainder of the observable universe. This formation is designated the KBC void, titled for the investigators who formally characterized it in 2013, Keenan, Barger, and Cowie. At 2 billion light-years in diameter, it ranks among the most extensive underdense territories identified anywhere in the observable universe. Let that register. Every galaxy we have examined, every supercluster we have titled, everything from our direct cosmic vicinity out to several hundred million light-years in every bearing. All of it resides inside a bubble of space with less substance than the universal norm. We inhabit a cosmic wasteland. The scientific standing here is forthright. The KBC void is backed by observational proof, but the severity of its underdensity remains debated. Some evaluations indicate it is more significant than others suggest. This is an active field of investigation, and the precise figures are still being calibrated. What is not credibly disputed is that we do seem to reside inside some measure of local underdensity compared to the wider universe. The specifics remain in continuing deliberation. What elevates this beyond a theoretical curiosity is what it could potentially clarify. For more than a decade, cosmologists have been wrestling with a difficulty termed the Hubble tension. The pace at which the universe is expanding when gauged using nearby objects in our regional area consistently registers roughly 9% greater than the identical pace gauged using the cosmic microwave background and the primordial universe. The two readings should coincide. They do not. And nobody possesses a completely satisfying account. One persuasive possibility is precisely this. If we inhabit an underdense territory, matter is less concentrated in our vicinity than in the typical universe. Gravity is marginally weaker locally. The regional expansion pace would be marginally greater than the worldwide average because there is less gravitational opposition drawing things back together. Our regional readings would appear elevated relative to the remainder of the universe. The instruments would be performing flawlessly. The locality simply stretches a bit differently. This continues to be a hypothesis meriting serious attention but not established. The Hubble tension may possess other accounts. Dark energy may be acting in unexpected fashions. There may be systematic inaccuracies in one or both gauging approaches, or all of these elements may be contributing simultaneously. What is definite is that we reside in a sparser than average territory of the universe, and the consequences of that are still being determined. The universe as we perceive it may be subtly skewed by the particular underdense pocket we happen to inhabit. This is a peculiar reality to internalize. Humans constructed their comprehension of the cosmos from within this specific territory of space. Every telescope aimed outward was aimed outward from within this underdensity. Every expansion pace gauged, every chart of galaxy arrangement produced, every calibration of cosmological frameworks, all of it was executed from within a pocket that diverges from the standard universe. We have been studying the universe from a somewhat atypical vantage point. Whether that has warped our portrait, and by what degree is a matter still being actively explored by research groups across the globe. And, if vacancy characterizes one extreme of cosmic architecture, the contrary extreme is something altogether different. because the cosmic web does not solely generate voids. It additionally generates barriers of galaxies so immense they test the mathematical boundaries of what ought to be feasible. In 2016, the Sloan Digital Sky Survey had been operating for over 15 years. It had charted hundreds of millions of galaxies spanning tremendous stretches of the sky, assembling the most comprehensive three-dimensional chart of the observable universe ever produced. Most cosmologists presumed that past a specific magnitude, approximately 1.2 billion light-years, the universe would appear statistically uniform and consistent in all bearings. This is termed the cosmological principle, and it had never been genuinely challenged. Then investigators J. Richard Gott III and Mario Jurich at Princeton University employed the survey information to quantify a formation already residing in the charts, one that had been partly recognized but never completely appreciated. When they computed its extent, the result emerged as 1.37 billion light-years. The Sloan Great Wall confirmed in October of 2003. It instantly became the most extensive known formation in the universe at that time. 1.37 billion light-years of galaxies organized in a plane observable across a tremendous sweep of sky, positioned approximately 1 billion light-years from Earth. Its complete extent is roughly 1/60th of the total diameter of the observable universe. It comprises numerous galaxy superclusters positioned along its length like municipalities along a corridor. The consequences extended past magnitude alone. A formation that enormous presents a real challenge to the concept that the universe appears identical at every scale. The cosmological principle maintains that if you withdraw far enough, the universe should look consistent with matter apportioned evenly, rather than concentrated into particular arrangements. The Sloan Great Wall was at the threshold of what standard frameworks could incorporate, precisely at the juncture where hypothesis and evidence began making uncomfortable contact. To appreciate why this is significant, think about what the cosmological principle actually declares. It declares, the universe examined at sufficiently grand scales possesses no favored location and no favored orientation. Matter is apportioned evenly. No territory is privileged. The same statistics hold everywhere. This presupposition supports nearly every cosmological computation ever performed, including the expansion pace of the universe, the age of the universe, and the anticipated destiny of the universe. If the presupposition collapses at sufficiently grand scales, a substantial portion of what we believe we understand becomes questionable. Astronomers devoted years to deliberating whether the Sloan Great Wall was a genuine continuous formation or merely a coincidental alignment of distinct components. Research has continued to endorse its reality as a unified, large-scale feature. It persists in the records of established megaformations. One method to appreciate its magnitude, if you journeyed along the Sloan Great Wall at the speed of light, the trip from one terminus to the other would consume 1.37 billion years. That exceeds the duration it required for complex multicellular life to advance from the earliest simple organisms into everything presently inhabiting Earth. The dinosaurs flourished and perished. Every ocean filled with novel species, land masses migrated, complete lineages of life emerged and disappeared, and you would still be en route. It maintained the distinction for the most extensive known formation for nearly a decade. It was recognized at the time as extraordinary, an anomaly, the type of thing that stretches limits without shattering them. The cosmological principle, straining beneath its magnitude, was still technically preserved. Then, a group of investigators in Hungary identified something else, something that rendered the Sloan Great Wall comparable to a minor notation in the chart. In 2013, a group of astronomers directed by István Horváth in Hungary produced an unanticipated finding. They were analyzing the distribution of gamma-ray bursts, the most energetic detonations in the observable universe, across a broad stretch of sky at a redshift of approximately 2. That situates them roughly 10 billion light-years distant. They identified a statistically noteworthy concentration of these bursts gathered in a particular territory of sky spanning the constellations Hercules and Corona Borealis. When they computed the magnitude of the territory generating that overdensity, the figure they obtained was exceptional. The formation extended somewhere between 6.5 and 10 billion light-years in extent. It has subsequently become designated as the Hercules Corona Borealis Great Wall, and it persists as the most extensive single formation ever catalogued in the observable universe. John Hakila, a professor of physics and astronomy who participated in the evaluation, described the finding straightforwardly. "We computed it," he said, and then understood, this is the largest thing in the universe. 10 billion light-years, 1/10 of the complete diameter of the observable universe. To traverse it at the speed of light would demand more time than the universe has presently existed. Not marginally less, more. The universe is 13.8 billion years old. Traversing this formation from end to end would require 10 billion years from one extremity to the other at the absolute maximum velocity physics permits. Stated differently, the universe itself would need to be a third older than it presently is before you concluded the traversal, and you would have been journeying since before our planet took shape. Here is why this constitutes a difficulty. Standard cosmological frameworks establish a theoretical ceiling on how enormous a continuous formation can be. Gravity has had 13.8 billion years to operate. In that span, the frameworks compute matter can only be drawn together and structured into formations approximately 1.2 billion light-years in extent at the absolute maximum. The Hercules Corona Borealis Great Wall is approximately 8 times grander than that ceiling. It should not be there. The formation is likely genuine. The statistical proof is substantial. Following evaluations with expanded data collections continue to endorse it, but its scientific standing remains at the tier of highly probable, not conclusively established as a genuinely unified continuous formation. The observational technique, depending on gamma-ray burst distributions rather than direct galaxy charting, carries particular limitations. Forthcoming missions may settle the matter. Until that point, the possibility resides in the information like an alert indicator nobody can account for. If established as an authentic formation, the consequences cascade outward into the underpinnings of cosmology. The standard framework that describes how formations develop would be flawed in a consequential manner. The chronology of cosmic development would require amendment. The mechanisms that molded the infant universe within the opening few billion years would need to have been more potent or more coordinated than we presently comprehend. Something constructed this at a magnitude our finest physics declares should be unattainable. There is one additional point to register. This formation rests 10 billion light-years distant. Light from the territory containing it has been traveling toward us for 10 billion years, and past approximately 18 billion light-years, something more enduring than distance begins to assert itself. There is a demarcation in space. It is not a barrier you could perceive or a terminus you could approach. It is a line established purely by the mathematics of expansion, and it rests approximately 18 billion light-years from Earth in every bearing. Past that line, space is stretching faster than the speed of light. Not because anything is traveling through space at unfeasible velocity, because the space itself separating us from those remote territories is elongating so swiftly that light, traversing it toward us, falls behind. It can journey toward us for billions of years and still conclude further from us than when it began, transported away by the stretching fabric beneath it. This is the cosmic event horizon, and it is established by the identical physics that forecasts black hole event horizons simply functioning at the magnitude of the complete observable universe rather than a solitary collapsed star. Every galaxy past 18 billion light-years is already severed, not obliterated, merely disconnected. Their light will never arrive here regardless of how long we persist. The transmissions they are emitting at this moment will journey toward us endlessly and never reach us. Here is the figure that renders this concrete. Every year, approximately 160 billion stars drift past that horizon, not in a solitary spectacular occurrence. Quietly, steadily, 160 billion annually, gliding past any feasible contact, permanently excised from the observable universe. This is established. The pace has been computed, verified, and documented. It is proceeding as you absorb these words. The present observable universe holds approximately 2 trillion galaxies, but that constitutes only roughly 6% of the complete volume of space. The remaining 94% is already permanently past our event horizon. We cannot dispatch signals there. We cannot receive transmissions from there. For every functional purpose, it no longer exists within the universe we can ever reach. And this figure is not constant. The event horizon is not a fixed demarcation. As dark energy persists in accelerating the expansion of space, the horizon's functional scope in certain aspects evolves over time. Territories we could hypothetically communicate with at present will ultimately go quiet as the expansion pace intensifies. Consider the magnitude of what that entails. The universe, we can presently detect that 93 billion light-year sphere containing 2 trillion galaxies is already a modest fraction of what exists out there. A fraction being further diminished annually at a pace of 160 billion stars per year. The universe we inhabit is contracting, not the physical space which is expanding. The portion of the universe we can reach, the portion we can investigate, the portion we can communicate with even hypothetically is diminishing annually. There is something philosophically profound about this that seldom receives acknowledgement. Every civilization that might persist in some remote galaxy at this moment, every conceivable variety of intelligence that might be gazing outward from its own world, confronts this identical shrinking horizon. Whoever they are, wherever they persist inside the observable universe, they are likewise losing their sky. Their event horizon is likewise drawing inward. Their access to the wider universe is likewise being quietly withdrawn, identical to ours, 160 billion stars at a time. The universe is converting into an assembly of isolated islands, gradually over incomprehensible durations but consistently. And the future direction of this progression leads somewhere considerably more isolating than anything we have examined so far. Because if you endure long enough, and here long enough signifies trillions of years rather than billions, what persists will be nearly inconceivable in its desolation. Envision a civilization 2 trillion years hence, not 2 billion, 2 trillion. That is approximately 145 times the present age of the universe. Any world capable of sustaining such a civilization would require a reliable stellar host, an extremely slow-burning red dwarf, and the endurance of profound time. What would that civilization be capable of detecting? Practically nothing of what we can observe at present. Established physics informs us what transpires as dark energy persists in accelerating expansion. Galaxy clusters beyond our local group are presently still detectable, but they are withdrawing. Across trillions of years, each one drifts past the cosmic event horizon. Individually, galaxy following galaxy dims below detectability, red shifted into quietude, driven past the demarcation where its light can ever arrive. In approximately 2 trillion years, founded on present expansion frameworks, every galaxy beyond our own local group will have crossed that demarcation irreversibly. The Virgo cluster, Laniakea, the Shapley concentration. All of those formations we charted with such diligence will be cosmically absent, not obliterated, merely inaccessible, unseen, mute. The evening sky of that future civilization will hold one galaxy, the combined remnant of the Milky Way and Andromeda, which will have finished their impact in roughly 4.5 billion years, producing a solitary, enormous elliptical formation. That formation, that single entity, will constitute the complete observable universe for anyone inhabiting it 2 trillion years hence. Here is the more fundamental difficulty. That future civilization will possess no means of recognizing what they are lacking. They will perceive a solitary galaxy enclosed by vacant darkness. They will possess no detectable proof that the universe once held 2 trillion more. The cosmic microwave background, the primordial radiance of the Big Bang that saturates our sky in every bearing and informs us how the universe commenced, will have been elongated by expansion until it descends beneath any conceivable detection limit. The temperature will diminish to a sliver of a degree above absolute zero. No apparatus will register it. They will determine reasonably and mistakenly that the universe is a solitary, unchanging galaxy in a boundless, perpetual void. No Big Bang, no expansion, no cosmic chronicle. Now contemplate what that signifies about the character of scientific understanding itself. All of cosmology, the complete enterprise of deciphering the genesis, architecture, and destiny of the universe, hinges on the capacity to detect proof that presently exists. If you had been born in that remote future period, the proof would simply be absent. No degree of brilliance or technology would assist. The data would be erased, permanently eliminated by the quiet devastation of expansion. The future is not merely solitary. It is epistemically sealed. It will be unfeasible to ascertain the truth. Lawrence Krauss articulated this with precision. We inhabit a very distinctive era. He said, the only time when we can observationally verify that we live at a very special time. This penetrates everything. The proof for the universe's chronicle is accessible right now in this period. And that accessibility is transient, which provokes the question of precisely when we are in cosmic time and what it signifies that we happen to be present to pose it. Review the complete chronology. The universe is 13.8 billion years old. The earliest stars materialized roughly 200 million years in the earliest galaxies, coalesced within the opening billion years. Our solar system materialized approximately 9 billion years following the Big Bang. Life emerged on Earth roughly 4 billion years ago. complex organisms arose approximately 500 million years ago. Modern humans have persisted for roughly 300,000 years. This specific juncture in cosmic time, the period we inhabit right now, possesses a particular and uncommon quality. It rests in what cosmologists progressively characterize as a golden age of detection, a limited window in cosmic chronicle. When all the proof required to decode the universe is still available and reachable, the cosmic microwave background is still registerable. It still saturates the sky with the subdued thermal imprint of the Big Bang. It can still be gauged, charted, and employed to establish the age, makeup, and geometry of the universe. In a handful of trillion years, that signal will be absent. Remote galaxies are still detectable. We can still perceive formations billions of light years distant. View the infant universe as it appeared hundreds of millions of years following the Big Bang, and establish the chronicle of cosmic development. In a handful of trillion years, those galaxies will be past the event horizon. The expansion of the universe is still apparent in the withdrawal of remote objects. We can still gauge the expansion pace, recognize dark energy's effect, and chart the large-scale architecture of the cosmos. In a remote future period, that proof will likewise be unreachable. Everything that enabled cosmology to function as a discipline, all of the detectable proof for how the universe operates is reachable within a particular window, and we happen to occupy it. Reflect on how remarkable that is. The universe is sufficiently aged that stars and worlds and biological systems have had opportunity to mature. Intelligence exists, technology exists, telescopes exist, and the proof of the universe's own chronicle is still streaming toward us from every bearing. These three conditions, sufficiently aged for complex life, sufficiently young for proof to endure, technologically equipped to interpret that proof, converge in a window that does not persist indefinitely. The window is calculated at approximately the opening 100 billion years following the Big Bang. We are 13.8 billion years in, early within the window. The proof is entirely still available. Every detection astronomers perform right now would be unfeasible for any civilization emerging after this period of cosmic time. Coming generations, if they persist far enough ahead in time, will receive a universe stripped of its chronicle. All the detections we are performing, every capture from every telescope, every reading of every remote galaxy may constitute the sole record that will ever exist of what this universe actually holds. That is an extraordinary burden to shoulder, and it directs a very particular question into focus, because up to this point we have solely been examining the portion of the universe we can perceive. Everything we have addressed, every galaxy, every void, every filament, every supercluster, constitutes only 5% of what is genuinely present. Everything examined up to this juncture, every galaxy, every star, every world, every atom of standard matter in the observable universe, all of it combined, constitutes merely 4.9% of what exists. Halt there. 4.9%. The remaining 95.1% is unseen by every telescope ever constructed. It generates no light, bounces no light, and captures no light. It cannot be imaged. It cannot be directly registered by any apparatus presently in service. And yet, it is present, established by multiple separate chains of proof so robust that its reality is no longer meaningfully disputed. What is disputed and still entirely unresolved is what it fundamentally is. Keith Beale, a physicist at the University of Wisconsin-Madison, described the circumstance plainly. This, he said, is a stringent test of the current standard cosmological model. A model asserting that 95% of the universe is dark matter and dark energy that we do not yet fathom. The division established by the Planck satellite's readings of the cosmic microwave background released in 2018 is exact. 4.9% is standard matter. That is everything you have ever perceived, handled, or quantified. Every star, every nebula, every black hole with an accretion disk luminous enough to capture every element on the periodic table, every molecule in every organism that has ever lived, all atoms, all chemistry, all matter that has ever engaged with light, 4.9% of the whole. 26.8% is dark matter, an unseen substance distributed throughout every galaxy and galaxy cluster, furnishing the gravitational framework that maintains the visible universe in position. The Milky Way exists within a dark matter envelope. Every formation in the cosmic web was constructed along dark matter filaments. The complete visible universe is a narrow luminous coating stretched over something we cannot perceive. 68.3% is dark energy, a force compelling the expansion of space to intensify with a theoretical basis so inadequately grasped that the foremost prediction from physics diverges by a factor of 10, raised to the power of 120. That is not a misprint. The theoretical forecast and the measured quantity differ by 120 orders of magnitude. It is the greatest disparity between hypothesis and observation in the complete chronicle of science. Combined, dark matter and dark energy form the commanding majority of existence. And we possess fundamentally no understanding of what either of them is at the foundational level. Contemplate what that implies for everything examined so far. Every filament of the cosmic web is a dark matter filament that galaxies happen to follow. Every galaxy cluster is sustained by dark matter. Every orbital velocity profile of every spiral galaxy mirrors the attraction of dark matter. Envelopes reaching far past the visible disk. The visible universe is in a concrete sense merely the luminous display generated by a formation we cannot perceive or contact. The actual universe by volume and by mass is overwhelmingly dark. The universe we have been investigating in such thoroughness is erected on a foundation we cannot perceive. And that foundation has been disclosing itself gradually across nearly a century, through the movements of objects and the curving of light in locations we least anticipated, discovering something unseen. Fritz Zwicky was not searching for unseen matter. In 1933, he was attempting to comprehend the Coma cluster, a concentrated assembly of approximately 1,000 galaxies, resting roughly 320 million light-years from Earth. He gauged the speeds of the galaxies within it. Then he computed how rapidly they ought to be traveling founded on the complete observable mass available. The figures were incorrect by a factor of several hundred. The galaxies were traveling so rapidly that the observable mass of the cluster could not generate sufficient gravity to maintain their cohesion. If solely standard matter existed in the Coma cluster, the galaxies should have been scattering apart ages ago. Something additional was present, something possessing tremendous gravitational mass that generated no registerable light. Zwicky termed it dunkle Materie, dark matter, and issued his determination in 1933. The scientific establishment largely overlooked him for 30 years. In the 1970s, astronomer Vera Rubin and her collaborator Kent Ford adopted a distinct methodology. They gauged how rapidly stars revolve within the outer margins of spiral galaxies. By the principles of gravity, stars remote from the galactic hub should revolve more gradually than stars positioned closer. For the identical reason, the distant planets of our solar system travel more gradually than the proximate ones. Rubin and Ford gauged galaxy following galaxy and discovered the identical, unexpected outcome everywhere. Stars at the outer margins were revolving just as rapidly as stars near the hub, occasionally more rapidly. The sole explanation that corresponds is unseen mass reaching far past the visible margins of every galaxy they examined. A tremendous dark envelope surrounding each one, furnishing additional gravitational attraction across the complete formation. In 2006, a pair of impacting galaxy clusters termed the Bullet Cluster furnished some of the most immediate proof yet. When two clusters impact, the heated gas in each cluster is decelerated by the impact and trails behind. If the majority of the mass were in that gas, the gravitational hub of each cluster would migrate toward the gas. Instead, readings revealed the gravitational hubs of both clusters had traversed directly through the impact zone without decelerating, plainly detached from the gas. The gravitational mass was not in the gas. It was in something that scarcely engaged with anything whatsoever, except through gravitational attraction. Dark matter had traversed through the impact as though the standard matter simply did not exist. As of 2026, not one particle of dark matter has ever been directly registered in a laboratory. The experiments hunting for it are extraordinary. Sensors buried deep underground, insulated from every conceivable source of disturbance, chilled to near absolute zero, anticipating a solitary dark matter particle to jostle a standard atom. Years of anticipation, trillions of particle interactions documented, and nothing. Zero established dark matter detections. Its nature persists as entirely unresolved. The contenders span from heavy particles termed weakly interacting massive particles to ultralight particles termed axions to primordial black holes generated in the infant universe. Every contender persists as unestablished. Dark matter constitutes the majority of all matter in the universe. It constructed the cosmic web. It sustains every galaxy. Every formation we have investigated exists owing to it. And we cannot identify what it is. But dark matter constitutes only 27% of the universe. The prevailing force, the one dismantling the cosmos at an intensifying pace, is something considerably more bizarre. In 1998, two separate groups of astronomers were performing something unremarkable. They were gauging the luminosity of detonating stars. Specifically, a variety of detonation termed a Type 1a supernova, which invariably generates a dependably uniform peak luminosity. That renders it a practical distance indicator. If you understand how luminous something genuinely is, and you gauge how dim it seems from here, you can determine precisely how remote it is. Both groups were employing this method to chart the expansion pace of the universe with accuracy. They anticipated establishing that the expansion was decelerating. Gravity has been drawing matter together since the Big Bang, and the presumption was that this attraction would be softly restraining everything. The strategy was uncomplicated. Gauge the deceleration, validate the frameworks, proceed. Instead, they discovered the reverse. The supernovae were dimmer than predicted, more remote than they should have been. The universe was accelerating. The expansion of space was intensifying and had been doing so for approximately 5 billion years. Something was pressing outward across the grandest magnitudes of the cosmos, overwhelming gravity everywhere, propelling everything apart at a perpetually growing pace. They designated it dark energy. Adam Rees, Saul Perlmutter, and Brian Schmidt shared the Nobel Prize in Physics in 2011 for this revelation. The intensification is established. The revelation is not in question. What generates dark energy persists as entirely unresolved. What we do understand is this. Dark energy functions like a characteristic of vacant space itself. Even a flawless vacuum emptied of every particle retains a foundational energy. Einstein originally incorporated a term in his equations, embodying precisely this variety of energy which he subsequently dropped when expansion was identified. The revelation of dark energy reinstated something very comparable to that term in the equations. Vindicated in the most unforeseen manner, the difficulty is the figures. Quantum field theory, the most precisely validated framework in all of physics, forecasts what the energy density of vacant space ought to be. When you derive it from foundational principles, the result emerges approximately 10 raised to the power of 120 times greater than what we actually detect. 120 orders of magnitude divergent. It is the greatest identified disparity between a theoretical forecast and a measured outcome in the complete chronicle of science. Nobody possesses a compelling account for why the measured quantity is so modest. What dark energy accomplishes is evident enough at cosmic magnitudes. It elongates the fabric of space more rapidly than gravity can contract it back together. At the magnitude of galaxies and clusters, gravity still prevails. The Milky Way faces no threat of being torn asunder. But at magnitudes exceeding superclusters, the contest has already been settled. Dark energy is prevailing. Annually, more of the universe intensifies past our grasp. In 2024, fresh outcomes from an apparatus termed the Dark Energy Spectroscopic Instrument suggested that dark energy may be transforming across time. The significance of those outcomes is presently assessed at roughly 3 sigma, which is indicative, but not yet decisive. Established or not, the implication is disquieting. If dark energy is shifting, our complete framework for the universe's trajectory may require revision. The intensification is genuine. The origin is an enigma. And somewhere within this expanding, intensifying universe rests the most ancient light in creation, arriving from every bearing simultaneously, conveying a message from before any galaxy ever materialized. Something is arriving at you from every bearing at this precise instant. You cannot perceive it. You cannot sense it. But it is present, quantifiable by any sufficiently responsive detector, permeating every cubic inch of space in the observable universe in all bearings simultaneously. A subdued, cold immersion of microwave radiation, the cosmic microwave background, the most ancient light in creation, and it is established, gauged in remarkable precision by multiple separate missions covering 40 years. To comprehend what it is, you must return to when the universe was extremely juvenile. For the opening 380,000 years following the Big Bang, the universe was excessively heated for atoms to form. The temperature was so intense that every instant a proton and an electron drew close enough to bond together. Adjacent photons instantly blasted them apart once more. The universe was an opaque, luminous plasma. Light could not travel beyond a brief distance before striking something and dispersing. If you could somehow position, yourself outside it, and peer in, the universe would have resembled the interior of a star, concentrated, blisteringly brilliant, impenetrable. Then the universe stretched sufficiently to cool down. Somewhere near 3,000 degrees, electrons at last surrendered enough energy to remain bonded to protons. Hydrogen atoms materialized. This instant is termed recombination, and it is established by multiple chains of proof. When it transpired, there was abruptly nothing remaining to disperse the light. Photons that had been confined for 380,000 years possessed a clear trajectory for the initial time. They radiated outward in every bearing simultaneously. We register those photons at present. Their temperature has diminished from 3,000 degrees at release to merely 2.726 Kelvin presently, which is 454.8 degrees below 0 Fahrenheit, barely above absolute zero. The expansion of the universe has elongated their wavelengths enormously, transitioning them from infrared light down into the microwave spectrum, far beneath what human eyes can register. A portion of the static in vintage analog television sets originated directly from this signal. Photons that had been journeying for 13.8 billion years arriving at the antenna. The subdued murmur of creation perceptible on a malfunctioning television set. The consistency of this signal is extraordinary. The temperature scarcely fluctuates from one section of sky to another. The deviations are merely approximately one portion in 100,000. But those minute differences carry tremendous significance. They embody the minor density variations in the infant universe that gravity subsequently magnified across billions of years into every galaxy, every filament, every void. We have examined the complete architecture of the observable universe was already inscribed in these deviations well before a solitary star had materialized. The surface from which this light was released rests 46.5 billion light-years distant in every bearing. That is the most remote point in time we can perceive using light. Prior to that, the universe was impenetrable. Our view terminates at 380,000 years following the Big Bang. Past that boundary of the visible chronicle, the infant universe persisted, and the universe as a totality, established to reach far past what we can perceive, is considerably grander than this sphere of primordial light. How much grander is a figure that transforms the magnitude of everything examined thus far? The observable universe is expansive. It is nearly certainly a minuscule fraction of the complete universe. The proof originates from geometry. Readings of the cosmic microwave background by the Planck satellite released in 2018 and established by multiple separate analyses demonstrate that the universe is geometrically flat. The angles of triangles traced across tremendous stretches of space total precisely 180 degrees, established to within 0.4%. This is a reality about the architecture of the universe, and it carries consequences. A flat geometry is mathematically consistent with one particular result: an infinite universe, a universe possessing no boundaries, no center, reaching in all bearings without constraint. Infinity is not established as conclusive reality. What is established is the flatness to the accuracy of present readings. Every data point gathered endorses it. From this foundation, investigators have determined how much grander the complete universe must be relative to the observable segment. In 2011, investigators Miran Vardanyan, Roberto Trotta, and Joseph Silk at Oxford University employed Bayesian statistical evaluation to the accessible information and derived a lower threshold. Their outcome, the complete universe, is at minimum 250 times grander than the observable universe in volume. That is the minimum, the baseline, the most compact it could be while persisting consistent with what we detect. Inflation advances this figure into an entirely different category. If space underwent the swift exponential stretching most cosmologists accept transpired in the opening minuscule fraction of a second following the Big Bang, then the complete universe would be at minimum 3 multiplied by 10, raised to the 23rd power times grander than what we detect. That is the figure 3 trailed by 23 zeros, employed as a multiplier to the 93 billion light-year sphere investigated throughout this expedition. At the far extreme, particular theoretical derivations propose the complete universe may be 10 raised to the power of 10 raised to the power of 122 times grander. Inscribing this figure would demand more space than the observable universe holds. It is significant solely as a mathematical construct. Even the conservative projection 250 times grander reshapes everything. The observable universe contains 2 trillion galaxies. At 250 times the volume, the complete universe contains at minimum 500 trillion galaxies, 500,000 billion galaxies, all functioning under identical physical principles, identical stars, identical chemistry, every formation investigated in this expedition, every filament and void and barrier repeated across a canvas 250 times more expansive at minimum. Likely far, far greater. Here is the element that renders this intimate rather than solely theoretical. If the complete universe is even 250 times grander than what we perceive, then the complete volume we have charted, every galaxy ever captured, every supercluster ever designated, every void ever traversed at the velocity of thought, constitutes less than 0.5% of what materially exists. Our most thorough depiction of the cosmos is a postage stamp on a canvas whose boundaries we cannot perceive. And if the universe is authentically flat and infinite, the duplications do not merely terminate somewhere. They persist without any constraint whatsoever, which generates a particular, profoundly unusual consequence that mathematics declines to relinquish. If the universe is infinite, you possess a duplicate. Trace the reasoning. The observable universe holds a finite quantity of matter. Quantum mechanics establishes a finite count of distinct configurations that any finite territory of space can assume. That count is inconceivably enormous, but it is finite. A finite collection of feasible arrangements of particles and energy within a territory the magnitude of our observable universe. In an infinite universe, a finite collection of feasible configurations must ultimately recur. Every arrangement of matter that can transpire must transpire somewhere, an infinite count of times. This is not conjecture. It is a mathematical characteristic of infinity itself, as definite as the principles of arithmetic. The physicist Max Tegmark at the Massachusetts Institute of Technology computed approximately how remote the closest territory of space arranged identically to our observable universe would be. His projection emerges at roughly 10 raised to the power of 10 raised to the power of 115 meters. This figure is so tremendous that there are no practical parallels to present. The observable universe itself covers fewer than 10 raised to the 27th meters. The separation to your closest identical territory renders the observable universe comparable to a solitary stride on an expedition traversing the complete Earth. But the separation does not alter the determination. If the universe is infinite, that territory resides within it, a world arranged identically to Earth, a duplicate of every continent, every metropolis, every chamber, a duplicate of you constructed from the identical atomic arrangement retaining the identical recollections up to this precise instant. That duplicate is authentically a distinct individual in the sense that experience is continuous and theirs is detached from yours. But the arrangement is identical. The choices being executed there are the identical choices. The reflections materializing there are the identical reflections. The words being absorbed there are these precise words. This is the most cautious variety of multiverse. Investigators designate it Level 1, and it necessitates nothing extraordinary, no supplementary dimensions, no alternative physics. Solely two elements, an infinite universe and identical physical principles functioning throughout it. Both prerequisites are consistent with all present readings. Neither has been contradicted by any detection. In an infinite universe, every conceivable variation of every conceivable individual exists somewhere. Not because the universe generated them deliberately, because the domain of conceivable arrangements is finite, and the universe is infinite, and consequently all of those arrangements materialize. Every result that did not transpire here transpired somewhere. Every direction not pursued here was pursued there. Some cosmologists regard this determination as an elegant and inescapable consequence of thoroughly validated physics. Others regard it as philosophically unsatisfying precisely because it can never be validated. Those duplicates exist past any horizon. They cannot transmit signals. They cannot be accessed. The division is permanent and absolute. And there is a more profound unease here. If identical duplicates of you exist and execute identical choices, what does that communicate about the perception of being a singular individual in a singular instant? The physics does not resolve that. It solely establishes the geometry and permits the question to remain there. The Level 1 multiverse necessitates solely that the universe persists, extending past the observable horizon. And thus far, nothing in the information indicates it terminates. But what follows poses a considerably more unusual question. It queries whether there might be complete universes where the principles themselves are wholly distinct. In 1981, a physicist designated Alan Guth at the Massachusetts Institute of Technology advanced the idea that in the opening minuscule fraction of a second following the Big Bang, space stretched exponentially, doubling in magnitude repeatedly in intervals so brief they possess no parallel in human experience. This mechanism, termed cosmic inflation, was advanced to account for several otherwise confounding attributes of the universe. Why does the cosmic microwave background appear identical in all bearings, even in territories that had no opportunity to interact? Why is the geometry so level? Inflation addressed both with sophistication. The observational forecasts it generates correspond to the information with notable accuracy. The proof for some iteration of inflation is compelling, established at the degree where treating it seriously is completely warranted. But inflation carries a consequence that even Guth did not entirely foresee. Terminating inflation consistently everywhere concurrently demands a very particular combination of prerequisites. Andre Linde demonstrated that in the majority of territories of space, the inflationary field persists in a high energy condition, and inflation persists indefinitely. In compact bubbles, quantum fluctuations prompt the field to diminish. Inflation terminates locally. And what materializes inside each bubble is a universe. Our universe is one such bubble. In the broader inflating domain surrounding it, additional bubbles are perpetually materializing. Each one constitutes a distinct universe. String theory proposes approximately 10 raised to the power of 500 conceivable stable energy conditions the field can settle into. Each condition would generate distinct physical constants, distinct particle masses, distinct magnitudes of the fundamental interactions, distinct chemistry. Numerous of those conditions would generate universes where stellar bodies cannot materialize, where atoms are unstable, where intricacy is unattainable. Some might generate more unusual arrangements we cannot envision from within our own collection of physical principles. Contemplate what altered constants would genuinely signify. If gravity were even marginally more powerful, stellar bodies would exhaust themselves within millions of years, rather than billions, providing no opportunity for worlds to materialize or life to emerge. If the strong nuclear interaction were less powerful, protons would not maintain cohesion. Atoms would not exist. If dark energy were even slightly greater, the universe would have stretched so swiftly following the Big Bang that matter could never have aggregated into anything whatsoever. We persist in a remarkably constricted range of physical constants. Bubble universes possessing altered quantities would predominantly be vacant, lightless, and featureless. This is termed the Level 2 multiverse. A tremendous assembly of bubble universes, each conceivably functioning under distinct physics, stretching away from one another inside an perpetual inflating domain they can never traverse to access each other. Here is the candid scientific standing. Eternal inflation arises from a framework possessing compelling observational endorsement. The bubble universes themselves reside past any detectable horizon, and by definition cannot transmit signals to us. There is no immediate proof for any of them. Investigations for conceivable signatures of an impact between our bubble and an adjacent one which would inscribe a mark in the cosmic microwave background have produced solely negative or inconclusive outcomes. Paul Steinhardt, one of the physicists who assisted in formulating inflation in the early 1980s, has emerged as one of its most incisive critics owing to precisely this. If inflation generates a multiverse where every conceivable result transpires somewhere, he contends, then the hypothesis generates no particular forecasts. Any detection becomes consistent with it. A hypothesis that can incorporate every outcome establishes nothing. That critique possesses genuine substance. The mathematics of eternal inflation are authentic. But the consequences have arrived at a juncture where physics and philosophy commence blending. And that introduces a challenge at the most fundamental level of how science functions. Science is constructed on one central prerequisite. A sound hypothesis must generate forecasts that observations could demonstrate incorrect. Without that, a hypothesis is not science. It is philosophy at most, unfalsifiable conviction at minimum. This criterion was expressed most distinctly by the philosopher Karl Popper, and the majority of practicing scientists acknowledge it as the minimum standard a hypothesis must satisfy to qualify as authentic understanding. The multiverse in the majority of its iterations fails this examination. If there are infinitely numerous universes possessing every conceivable collection of physical principles, no detection you can perform in this universe could be incompatible with that. Hypothesis. Every conceivable result is incorporated somewhere. The hypothesis cannot be disproven, and a hypothesis that cannot be disproven cannot be established either. It merely encompasses everything and accounts for nothing. This is a critique originating from within the physics community, from investigators who devoted careers formulating the very hypotheses producing the multiverse. Steinhardt expressed it directly. In a multiverse, any result is equally feasible. So, inflation generates no forecasts. Leonard Susskind at Stanford University, who advocated the string theory landscape and its relationship to the multiverse, publicly declared in 2024 that he is completely certain that string theory as a comprehensive theory of everything does not characterize reality. He was not dismissing all of its mathematics, but the admission carries significance from one of the concept's most visible champions. In 2014, investigators Jot Singh Kohli and Michael Haslam released an evaluation proposing that eternal inflation may not genuinely be eternal. Their modeling of the inflating field demonstrated that solutions diverge in finite duration. If inflation concludes everywhere, the bubble-generating mechanism halts. Numerous cosmologists challenge their evaluation. The discourse continues. There is something crucial to acknowledge about this juncture in science. The difficulty is genuine, but it is not an indication of defeat. It is an indication of advancement, arriving at a novel variety of frontier. Every preceding era of physics ultimately encountered a barrier that demanded fresh instruments, fresh mathematics, and fresh approaches to thinking to surmount. Classical mechanics functioned until it encountered the atom, and quantum mechanics was constructed to advance further. General relativity characterized gravity magnificently, until it encountered singularities and the commencement of the universe, and inflation was formulated to extend past those constraints. The SI's present frontier is distinct in nature. Prior barriers were empirical. You could construct fresh instruments and measure your passage through. The multiverse frontier may be epistemological. The data required to examine it may simply not reside within any detectable territory. That is a novel variety of obstacle, and science does not yet possess a consensus resolution for how to manage it. Contemplate what this juncture embodies in the wider narrative. Humanity charted the observable universe spanning 93 billion light-years. We determined the makeup of reality back to the opening fraction of a second. We projected the trajectory of the cosmos across trillions of years. All of this from a solitary world circling an ordinary star in one galaxy among 2 trillion. And we have arrived at a frontier. The frontier of what science can presently determine past the observable universe. Physics either persists as it does here, or it fluctuates bubble by bubble across a perpetual inflating expanse. Or the question resides permanently outside the scope of any detection. We do not understand which. The proof that would differentiate between these possibilities may not yet exist, or it may never exist. What is not in question is the magnitude of the established universe itself. And within that established universe, one photograph captured on a particular day communicates something about our position within it that no figure can entirely convey. Valentine's Day, February 14, 1990. Voyager 1 had been journeying away from Earth for over 12 years. Engineers determined that before the probe traveled past the distance where a camera instruction could effectively execute, there was a narrow window to redirect its instruments back toward home. The concept originated from Carl Sagan, who had campaigned for this photograph for years, despite the resistance of team participants who highlighted its negligible scientific utility. Sagan persisted. The instruction was dispatched. the eye's resulting capture displays a scattered beam of light traversing the frame. In that beam, faint, scarcely a pixel in width, a pale blue speck. Earth. Voyager was 3.7 billion miles from Earth when it produced that photograph. By any human standard, that is an unfathomable separation. By cosmic standards, it is fundamentally the front step of the residence. The closest other star is 25 trillion miles distant, approximately 7,000 times more remote than Voyager was. The center of the Milky Way is roughly 260 million trillion miles distant. The closest major galaxy is 25 million trillion miles distant. The boundary of the observable universe is roughly 70 trillion times more remote than Voyager's location. The Voyager probe, dispatched in 1977, persists as the most remote human-constructed object in existence. Nearly 50 years of uninterrupted transit at approximately 38,000 miles per hour, and it has scarcely departed the front yard. At its present velocity, it would require approximately 73,000 years to arrive at the closest star. The observable universe boundary at that velocity would demand a transit of roughly 1.7 billion years. We constructed the swiftest object in human chronicle, and it cannot substantively diminish the separation to even our nearest neighbor. Every conflict ever conducted, every dominion that emerged and collapsed, every ocean traversed, every countenance cherished, every instant of anguish and elation across hundreds of thousands of years of human existence. All of it transpired on that pixel. Carl Sagan composed about it with precise language. That speck, he said, is here. It is home. It is us. On it. Everyone you cherish. Everyone you recognize. Everyone you ever learned of. Every human being who ever existed conducted their lives. The totality of elation and anguish. Thousands of assured religions, philosophies, and economic systems. Every hunter and gatherer, every champion and coward, every innovator and demolisher of civilization, every sovereign and commoner, every young pair in love, every optimistic child resided there on a particle of dust floating in a shaft of light. He was not being lyrical. He was being exact. The photograph is a data point. The information declares that everything humans have ever deemed significant transpired on an object unseen in virtually every cosmic capture ever produced because it is too diminutive and too faint to register. Our pretensions, he continued, our fabricated self-importance, the illusion that we possess some favored station in the universe, are confronted by this speck of pale light 3.7 billion miles, our front step, the greatest separation from which anyone has ever photographed Earth. And from there, it scarcely appears. Somewhere far past that pale speck, the complete duration of human existence compresses into a sliver of time so narrow it nearly vanishes against the complete magnitude of cosmic chronicle. The magnitude of space is one variety of vertigo. The magnitude of time generates something entirely distinct. And what you discover when you position everything humans have ever accomplished against the chronology of the universe may be the most challenging element in this complete expedition to retain. Compress the complete chronicle of the universe into one calendar year. Let January 1st at midnight represent the Big Bang 13.8 billion years ago. Let December 31st at midnight represent this very instant. Every individual day on this calendar embodies approximately 37.8 million years of actual duration. The Big Bang ignites at the opening instant of January 1st. For the opening several weeks of this calendar, The universe holds solely hydrogen, helium, and trace lithium. No stellar bodies, no luminous points in the blackness. The earliest stars kindle around January 22nd. They are enormous, ephemeral, and their terminations distribute heavier elements through space for the initial time. Gradually, across weeks of calendar duration, galaxies commence, assembling. The Milky Way materializes around March 16th. Still juvenile, still expanding, the cosmic web is taking configuration in every bearing. By early September, a formation of gas and dust in one arm of the Milky Way commences contracting. September 2nd, a fresh star at the center of that formation kindles. September 21st, a compact rocky world hardens in orbit around it. That world is Earth. The earliest life materializes October 3rd. Single-celled, fragile, elaborating the chemistry of survival. It requires until November 21st for photosynthesis to materialize until December 5th, for the earliest complex multicellular organisms to emerge in the waters. December 13th, vertebrate fish. December 20th, the initial forests. December 25th, one of the major extinction catastrophes, eliminating the bulk of species existing at that period. December 28th, the earliest dinosaurs materialize. They endure across multiple complete days of this calendar. They are remarkable in their diversity and supremacy. Then, on December 30th, the asteroid impacts. December 31st. In the hours preceding midnight, small mammals branch into configurations we identify. Later in the evening, the primate lineage diverges from the forebears of everything else. By late evening, the forebears of contemporary humans materialize. And then, in the concluding 10 seconds preceding midnight, everything that human beings have ever accomplished transpires. 10 seconds, the entirety. Agriculture, the earliest settlements, ancient Egypt, encompassing 3,000 years of civilization. Greece, Rome, the medieval period, the Renaissance, the scientific revolution, the industrial revolution, every conflict, every revelation, every countenance ever recognized, every dominion ever erected or demolished. The Wright brothers, nuclear armaments, the lunar landing, the digital age. This precise instant. 10 seconds on a calendar embodying 13.8 billion years. The dinosaurs possessed December 28th through December 30th, 2 complete calendar days, 160 million years of genuine existence. They were present 240,000 times longer than our civilization has persisted, and they are extinct. Contemporary humans, signifying our species possessing approximately our cerebral architecture, have persisted for roughly 300,000 years. On this calendar, that amounts to less than 0.8 of a second. Our most ancient artifacts extend back perhaps 40,000 years, half a second. The development of writing, the element that divides documented chronicle from prehistoric times, transpired roughly 5,000 years ago, less than 1/10 of a second. Everything you have ever been instructed about human chronicle, every prominent figure, every civilization, every conflict, every advancement in science or art or governance transpired within that 10th of a second, residing at the terminus of December 31st. After over 8 months of the universe persisting before Earth even materialized, this portrait held alongside the separations and the voids and the formations generates something between two sensations. One is a heaviness that is difficult to articulate. The other demands looking in an entirely different bearing, back to where the atoms in your body originated long before Earth existed. Commence with the iron in your blood. that iron was manufactured inside a perishing star. This is an established physical mechanism. Iron cannot be generated in the Big Bang. The Big Bang manufactured hydrogen, helium, and trace lithium. Everything weightier demanded the interior of a star possessing adequate temperature and pressure to combine lighter atomic nuclei into weightier ones. Carbon manufactured in helium fusion. Oxygen constructed from carbon, silicon, sulfur, and ultimately iron, constructed layer upon layer in the core of a massive star, as it consumed progressively weightier fuel. When that star ultimately accumulated sufficient iron in its core, it could no longer produce energy through fusion. Iron. Fusion consumes energy rather than liberating it. The core imploded. In a fraction of a second, it contracted from a body hundreds of miles in breadth to something approximately 10 miles across, then rebounded outward in a detonation so ferocious it momentarily outshone the combined luminous output of every star in the galaxy. A supernova. The weightier elements manufactured in that detonation, comprising many of the trace elements in your body, were dispersed throughout the adjacent space. Billions of years afterward, some of those atoms migrated in a gas formation in the Milky Way. Gravity drew the formation inward. A fresh stellar system condensed from the substance. The surplus mass, comprising that iron from the deceased star, accumulated into revolving rocks that ultimately cooled and consolidated into a world. You are composed of that world, and that world was composed of that deceased star. And that deceased star was composed of prior stellar detonations extending back through generations of cosmic recycling to the hydrogen that originated from the Big Bang itself. The calcium in your skeletal structure was manufactured in stellar cores. The oxygen you are inhaling was generated by stellar fusion and dispersed by supernovae. The carbon, constituting the backbone of every biological molecule in your body, is stellar residue. The iron transporting oxygen through your circulatory system was manufactured in a star that detonated billions of years before Earth materialized. Neil deGrasse Tyson has termed this the most remarkable reality he is aware of. The atoms that constitute life on Earth, he elaborated, are traceable to the cores of high-mass stars that detonated their enriched substance into the galaxy, supplementing gas formations with the chemistry of life. Here is what that signifies. The universe did not merely generate a setting against which life happens to persist. The universe constructed the substance that became life through an uninterrupted sequence of physical mechanisms extending across billions of years and innumerable generations of stellar termination and regeneration. The demarcation between you and the universe is less distinct than it seems. You are the universe structured into an arrangement capable of examining itself. Every cosmological mechanism in this expedition connects in a direct physical sequence to this precise instant. The Big Bang generated the hydrogen. Stellar fusion constructed the weightier elements. Supernovae dispersed them. Planetary development concentrated them. Chemistry structured them into intricacy. And here you are, constructed from cosmic fragments, conscious of where you originated. The magnitude that appears to diminish us is the identical magnitude that constructed us. And what that signifies for everything else merits one concluding examination of the complete portrait. Absorb everything. 93 billion light-years in extent. 2 trillion galaxies, at minimum 10 raised to the power of 24, individual stars. a cosmic web of dark matter filaments extending in every bearing constructed across 13.8 billion years from the most subtle quantum fluctuation in the opening fraction of a second. Voids so barren that traversing them at the speed of light consumes more duration than complex animal life has occupied Earth. Formations so enormous that a transit from one extremity to the other would exceed the present age of the universe. At the unseen segment, dark matter sustaining every galaxy, established by every observational approach except direct registration. Its nature entirely unresolved after nearly a century of investigation. Dark energy propelling the expansion of space at an intensifying pace with a theoretical forecast so divergent that the disparity is the greatest identified shortcoming in the chronicle of quantitative science. Together, 95% of existence unseen, unregisterable, prevailing, add trillions of years. Hence, every galaxy beyond our local group will have traversed the cosmic event horizon irreversibly. The cosmic microwave background will have diminished beneath any conceivable detection limit. Future inhabitants will gaze outward and determine accurately by every reading accessible to them that they inhabit a solitary perpetual galaxy in a vacant void. They will possess no means of recognizing what was forfeited. The data will simply be absent. Now contemplate the established lower threshold. The complete universe is at minimum 250 times grander than what we have just investigated. Every galaxy, every void, every filament, every formation we designated, repeated across a canvas 250 times more expansive at minimum. Inflation frameworks advance that multiplier toward figures that cannot be inscribed in any accessible space. And then position yourself within all of this, on a world that constitutes one pixel in a photograph captured from our cosmic front step. In a civilization inhabiting 10 seconds on a calendar of 13.8 billion years, constructed from atoms manufactured in stellar detonations that preceded Earth, residing inside the constricted golden window of cosmic chronicle, when the proof of everything that transpired before is still available in the sky, still registerable, still interpretable. Christopher Consolis, who determined the 2 trillion galaxy total, observed that 90% of those galaxies have never been examined. The golden age of revelation is transpiring right now in this period with the apparatus we have constructed in the window that will not persist open indefinitely. Lawrence Krauss was exact. We inhabit a very distinctive era. The sole era when we can observationally establish that we inhabit a very distinctive era. There is a sensation that materializes when you retain all of this simultaneously. The universe is enormous past any manageable magnitude, predominantly unseen, predominantly vacant, and completely indifferent to whether any segment of it is ever comprehended. It will persist expanding, regardless of whether anything observes it. The voids will persist deepening. Dark energy will maintain its patient, inexorable labor. And yet, in this specific territory, on this specific world, in this specific 10-second interval, a modest portion of the universe structured itself into configurations that pose questions about all the remainder of it. That is not mandated by any physical principle anywhere. It is not forecasted by any equation. It merely transpired. The identical universe that constructed the Hercules Corona Borealis Great Wall constructed the consciousness capable of quantifying it. The identical expansion that will ultimately quiet every remote galaxy generated the brief temperate interval in which that quietude has not yet materialized. That is where we reside, inside the window, eyes open while the light still arrives. And perhaps that is the most extraordinary element of all. Not the magnitude of the cosmos, not the darkness that commands its architecture, not the accelerating silence swallowing its boundaries, but the improbable, fleeting reality that something within it became aware. That atoms assembled in the furnaces of long-vanished stars organized themselves into beings capable of charting the very web from which they emerged. We did not merely appear in the universe, we emerged from it, woven from its substance, animated by its processes, and granted a narrow interval in which to comprehend what constructed us. The window will not remain. The light will eventually fade. The proof will be carried away by the same expansion that once delivered it. But right now, in this brief, luminous instant, the universe is still speaking, and we are here to listen.